Welcome to the Beamy channel. Have you ever looked up at the night sky and wondered if we're alone in the universe? It's a question that has fascinated us for centuries. Today, we're going to explore the concept of habitable zones and the search for Earth-like planets in our galaxy. We'll also dive into the exciting possibility of life on exoplanets. So, buckle up and let's get ready for a cosmic journey. Let's start by understanding what a habitable zone is. Imagine a star as the center of a bullseye target. The habitable zone is the ring around that star where conditions might be just right for life as we know it. Scientists often call this the Goldilocks zone because it's not too hot and not too cold. In this zone, a planet could potentially have liquid water on its surface. Water is crucial for life as we know it, so finding planets in this zone is exciting. Our own Earth sits comfortably in the Sun's habitable zone. But what about other stars and their planets? That's where the search for exoplanets comes in. Exoplanets are planets that orbit stars other than our Sun. Astronomers have discovered thousands of these distant worlds. Some of them are in their star's habitable zone, making them particularly interesting. One way scientists find exoplanets is by looking for tiny dips in a star's brightness. These dips happen when a planet passes in front of the star, blocking some of its light. This method is called the transit method. Another technique is the radial velocity method. According to the organization, Universe Today, one of the greatest advantages of the transit method is the way it can provide accurate constraints on the size of detected planets. This is based on the extent to which a star's light curve changes as a result of a transit. Whereas a small planet will cause a subtle change in brightness, a larger planet will cause a more noticeable change. When combined with the radial velocity method, which can determine the planet's mass, one can determine the density of the planet. From this, astronomers are able to assess a planet's physical structure and composition. It looks for tiny wobbles in a star's motion caused by the gravitational pull of orbiting planets. Now, let's talk about some exciting exoplanet discoveries. Kepler 186f was one of the first Earth-sized planets found in a habitable zone. It orbits a red dwarf star about 500 light-years away from us. TRAPPIST-1 is another fascinating system. It has 7 Earth-sized planets, 3 of which are in the habitable zone. These discoveries have sparked a lot of excitement in the scientific community. But finding a planet in the habitable zone doesn't guarantee it's Earth-like. Many factors come into play. The planet's size and composition are important. Is it a rocky planet like Earth, or a gas giant like Jupiter? The planet's atmosphere also plays a crucial role. An atmosphere helps regulate temperature and can protect the surface from harmful radiation. Speaking of atmospheres, how do we study them from so far away? One method is called transit spectroscopy. Transit spectroscopy is a technique that astronomers use to study the atmospheres of exoplanets by measuring the light from a star during a planet's transit. When a planet passes in front of its star, some of the starlight filters through the planet's atmosphere. By analyzing this light, scientists can learn about the atmosphere's composition. They look for signatures of gases like oxygen, methane, or water vapor. These could be signs of life as we know it. But life might not always look like what we're familiar with on Earth. That's why scientists are open to the idea of weird life. This could be life based on different chemistry or thriving in conditions we consider extreme. For example, some propose that life could exist in the subsurface oceans of icy moons like Europa or Enceladus. These moons aren't in the traditional habitable zone, but they might still harbor life. The search for life on exoplanets faces many challenges. The vast distances involved make direct observation difficult. Even our closest stellar neighbor, Proxima Centauri b, is over 4 light-years away. That's more than 40 trillion kilometers. Future telescopes and missions aim to overcome these challenges. The James Webb Space Telescope, launched in 2021, is already providing new insights. It can study exoplanet atmospheres in unprecedented detail. As we search for life beyond Earth, we're also learning more about our own planet. Studying exoplanets helps us understand what makes Earth special. It gives us perspective on our place in the cosmos. The field of astrobiology combines astronomy, biology, and geology to study the potential for life in the universe. It's a reminder of how interconnected scientific disciplines can be. The possibility of finding life on exoplanets raises interesting questions. How would such a discovery impact our understanding of life? What would it mean for our place in the universe? These are questions that scientists, philosophers, and the public continue to ponder. As we wrap up our cosmic journey, let's remember that the search for life beyond Earth is ongoing. Every new discovery brings us closer to answering that age-old question: are we alone in the universe? Whether we find life or not, the quest itself expands our knowledge and imagination. It reminds us of the vastness and wonder of the universe we call home. There is so much to cover and discover. If you enjoyed this video, please like and share it with others who might be curious about space and exoplanets. Don't forget to subscribe for more videos exploring the mysteries of our universe. Until next time, keep looking up and wondering about the possibilities that lie among the stars. This is Beamy, sounding off.